Welcome back for the lesson 5.3 video. We are going to work on addition and subtraction of rational expressions. So addition and subtraction of rational expressions means we're adding fractions. And so we're going to go back to some of our rules of adding fractions just to remind ourselves. When the fractions have the same denominator, then you can add the numerators and simplify. So 5/6 plus 1/6 means that we have denominators that are the same size, 6, so we can add the numerators. In this case, we get 6/6, which equals 1. Example 2, we have two fractions that have the same denominator. So again, we can add the numerators, 5x plus 2, and we keep the denominator 5x plus 2, and that happens to reduce to 1. That won't always work. Okay, so again, example 3, we have the same denominator, so we can subtract. So we're going to have 2x minus 4, subtracting x, subtracting a negative 6 makes a positive 6, all over x plus 2. Then when we combine like terms, we have 2x minus x, so that leaves us with an x minus 4 plus 6 is a plus 2 over x plus 2, which again equals 1. These just happen to equal 1. So when you add your fractions, they will not always equal 1. Now, if we add and subtract fractions with different denominators, we have to get them to a common denominator or a common size, or we can't add the numerators. We're not going to be adding like things or subtracting like things. So for instance, we have 5/8 minus 1/4. So I know that I can multiply this by a 2/2, and I will get to 2/8. So now we have two fractions with the same denominator. So 5 minus 2/8 is 3/8. Okay. Now in example 5, I have 3, 6, and 12. 12 is going to be my common denominator. So I have to multiply 1/3 times 4/4 to get to a denominator of 12. And I have to multiply 5/6 times 2/2 to get to 12. So I end up with 4/12, subtracting 10/12, adding 5/12. And now that they all have a denominator of 12, I can combine the numerator. 4 minus 10 is a negative 6 plus 5 is a negative 1. So let's look at examples. We're now moving into some expressions that have letters, they're not just numbers. So I have 3/a plus 2/a squared minus 1/a cubed. So my least common denominator is going to have to be a cubed because it has to be the one that has the most number of a's. So this first fraction needs a squared, two more a's to make it even with a cubed. So I need a squared over a squared. And then the second fraction needs a over a. So I then have 3a squared plus 2a minus 1 all over a cubed. Because now they are all a cubed, a cubed, a cubed, a cubed. And these are not like terms, so they are as combined as they can be. I'm going to skip a few. If you want to catch the extra lesson video, you can, but you're not required to. So I'm going to skip to example 9. Example 9, I want to get to a common denominator. So to do that, I have to see what factors they have in common. So I just have x minus 2 over here. And if I factor out 5, I get 5 times an x minus 2. So it looks like this fraction just needs to be multiplied by a 5/5 so that it will be the same denominator. So if I do that, I have to multiply this numerator 5 times x plus 1. So I have 5x plus 5 minus, and I have to subtract this 4x plus 7. So it's minus 4x minus 7 all over 5 times x minus 2. Now I'm going to leave my denominator factored because it will actually probably help me simplify in the end. So 5x minus 4x is x, plus 5 and a minus 7 is minus 2 over 5 times x minus 2. And yes, I can factor or cancel out the x minus 2's, and I'm left with 1 over 5. I'm not left with just 5. It's a fraction of 1 over 5. Now, example 10, I'm going to have to do the same. If I was to simplify these and add them, I have to factor the denominators to find the least common factor. And then that's going to factor into x minus 6, x plus 6. Okay, so my LCD has to include each factor the most number of times it occurs. So 2, and then they both already have an x plus 6, so that's included, but I don't need to worry about it too much, and then an x minus 6. Okay. So now this fraction here has the 2 and an x plus 6, but it's missing the factor of x minus 6. So I have to multiply it by x minus 6 over x minus 6. And then this fraction here has the x minus 6, x plus 6, but it's missing a 2. So I have to multiply by 2 over 2. So I end up with x minus 6, x plus 7 plus 6 times 2 is 12, all over 2 times x minus 6, x plus 6. Now I'm going to multiply my binomials together, so I get x squared plus x minus 42 plus 12 equals x squared minus x minus 30. And I can factor that into x minus 6, x plus 5. And this is always over the same denominator here. X plus 6. So it looks like my x minus 6 is canceled. So my final answer is x plus 5 all over 2 times x plus 6. When I multiplied these, this should have been a plus x. So this should have been plus 6 minus 5. So that should be minus 5, and then the x plus 6 would cancel, and this should be minus 6. So let's rewrite this. Should be x minus 5 over 2 times x minus 6. My corrections. I'm glad I looked that over. Sorry about that. Okay. A couple more problems here just for fun. So example 11. Again, I have to factor to see what my least common denominator can be. So 2t minus 5 doesn't factor, but this, ooh, this could factor into, let's see. That's a tough one. I think 8t is going to be too big. So 8t and 5 and 3, or 3 would be 6 and 5. Okay, so if I do 3 and 5, I need the bigger one to be negative. So a negative 20 plus 6 is a negative 14. So that works. Well, that was a tough one. Okay, so they both have a 2t minus 5. So my LCD is going to be 2t minus 5 and 4t plus 3. So the first fraction is missing 4t plus 3 over 4t plus 3. So we're going to distribute that. So that's going to be 12t plus 9. And then the second fraction has everything we need. So that just stays at plus 21 over, and I'm going to leave them factored, 4t plus 3 times 2t minus 5. So this becomes 12t plus 30. And I guess we could factor out a 6, and I'll have 2t plus, but I'll have 2t plus 5. So that doesn't even help me. So 12t plus 30 over 4t plus 3 times 2t minus 5 is as simplified as it gets. Let's look at example 12. Example 12 is a good one because it forces us to practice difference of 2 cubes and difference of squares to get our factors for the LCD. So 27 cubed minus 1 is really 3x cubed minus 1 cubed. So it's a difference of 2 cubes. So A is 3x and B is 1. So it factors into 3x minus 1 times 3x squared, or 9x squared, plus 3x plus 1. And then 9x squared minus 1 is a difference of 2 squares, 3x squared minus 1 squared. So 3x minus 1 and 3x plus 1. So my LCD is the 3x minus 1, and then 3x plus 1, and then the 9x squared plus 3x plus 1. So the first fraction is just missing 3x plus 1. So 3x plus 1 over 3x plus 1. And the second fraction is missing the 9x squared. Oh, no. Yes, it's missing the 9x squared plus 3x plus 1. So I have 3x plus 1 subtracting 9x squared, subtracting 3x, subtracting 1, all over 3x plus 1, 3x minus 1 times 9x squared plus 3x plus 1. Then I can combine my numerator. 3x minus 3x cancels, 1 minus 1 cancels, and you're left with minus 9x. So the final answer is minus 9x squared over 3x plus 1, 3x minus 1, 9x squared plus 3x plus 1. And I'm going to do example 16 as my last one. Like I said, if you want to catch back for an extra video for other topics, you may do that. Example 16, let's do one last one where we're adding and subtracting, but we have 3 unlike denominators, so we have to factor them to find our LCD. So we x plus 3 as is. This one factors into 3 times x plus 3. And this one will factor to x times x plus 3. So it looks like the least common denominator is a 3 and an x plus 3. So the first fraction is only missing a 3x. And the second fraction is just missing an x over x. The last fraction is just missing a 3 over 3. And they're all over the denominator of 3 times x plus 3. So we have 3x squared plus 7x minus 6. And not sure if we can factor. Can we factor this? Let's see. I'm just going to write that down here. Can we factor in a 3x and x? 2 and 3, 6 and 3, no. 3 and 3. So 9 minus 2, yeah, so that would be right. So this would be plus and this would be minus. 9 minus 2 is the positive 7, and that's a minus 6. Okay, so this factors into 3x minus 2 times x plus 3 over 3x times x plus 3. And those cancel, and we're left with 3x minus 2 over 3x. Excellent. Woo. Catch me back for lesson 5.4.